Yeah, we're going to do some extra examples of finding the slope of lines that are parallel and perpendicular to other lines. Um, Again, as always, watch the parts you need help with, watch it all if you need it all, and ask questions if you're still stuck. So one way we can find the slope of parallel and perpendicular lines is if we look at the graph of a line. So the first thing I would need to do is find the slope of this line like we did in the last lesson. And so the slope of this line is going to be negative because it's going down to the right. And I'm going down 1, that's my top number. To the right 3, that's my bottom number. So this line has slope negative 1/3. And so what I want to do is find the slope of a parallel line. And I denote that like this. Those two symbols mean parallel. And we know that two lines that are parallel will never touch. That means they'll be slanted the same way, they'll be sloped the same way, and so their slopes will be exactly the same. So any line that I draw that is parallel to this blue line is going to have the very same exact slope. There are two things that make a line unique: their slope and where they cross the y-axis. So we can draw as many lines as we want that are parallel to this blue line as long as it has the same slope of negative 1/3. So I could draw a point and I could go down 1 to the right 3, and if I made a line, oops, if I made a line through there, that line would be parallel to the blue line. And it should look like those two lines would never touch because they're parallel, they have the same slope. Perpendicular lines, they're going to have slopes that are related but are different in two ways. We always, when we have perpendicular lines, one slope is negative and one slope is positive. So my perpendicular slope, perpendicular is that upside down T, is going to be positive since my regular slope was negative. And then I'm going to take the fraction and flip it over. So instead of 1/3, I have 3/1. So my perpendicular slope is 3/1. Any line that has a slope of 3/1 is going to be perpendicular to this blue line. Perpendicular again means they make right angles. So if I take any point and I go up 3, 1, 2, 3, and to the right 1, and then I graph a line, it should look like those two lines are perpendicular. They'll make right angles. And actually you can see that that is also perpendicular to the parallel line I drew. Let's find the slope of this line. It's going to be positive. It goes up to the right. 1, 2, 3, 4. 1, 2, 3. So my slope is 4/3. That means the slope of any line parallel to this line is going to be exactly the same, 4/3. Since my blue line has a positive slope, my perpendicular line will have a negative slope, opposite signs. And then opposite fraction. That means I'm going to flip that 4/3 and get 3/4. So my perpendicular line is going to have a slope of negative 3/4. Change the sign, flip the fraction. And then this last one is going to have a positive slope again because it goes up to the right. I go up 1, to the right 2, so my slope is 1/2. So again, my parallel line, any line I draw parallel to that blue line is going to have the exact same slope. Again, if I have a point and I go up 1 to the right 2, that's that slope of 1/2, and I draw a line. That line should look parallel. It'll never touch the blue line because they have the same slope. They're slanted the same way, and so they're never going to intersect each other. That makes them parallel. Perpendicular, I change the sign, so my perpendicular is going to be a negative slope, and then I flip that fraction over to 2 over 1. So again, if I just pick any point, I'll go down 2 to the right 1. If I graph a line through those points, you can see that that line is perpendicular to my other lines, the ones that are parallel. That one's perpendicular. It would make right angles. Another way we can find parallel and perpendicular is just to find the slope given 2 points, and so we do that using the slope formula that I write every time, and then I label my points x1, y1, x2, y2. So y2 is 19, minus from the formula, y1 is negative 10, x2 is 14, minus from the formula, x1 is negative 16, so I get a slope of 29 over 30. And so my parallel line is going to have the exact same slope of 29 over 30, positive. My perpendicular line is going to be negative because they have to have opposite signs, and then I will flip the fraction, 30 over 29. So I use my slope formula to figure out the slope of the line that is between these 2 points. So if I graph these 2 points and I connect them with a line, it will have a slope of 29 over 30. The parallel line will have a slope of 29 over 30, and the perpendicular line will have a slope of negative 30 over 29. Slope formula every time, and you'll memorize it. You'll never forget it. That x1, y1, x2, y2. So my y2 is 13, and there's a minus in the formula. Y1 was 16. X2 is negative 1. There's a minus in the formula. X1 is negative 5. So I get negative 3 over positive 4. And so the slope of my parallel line is going to be negative 3 over 4. Remember that one negative belongs to the whole fraction. It means that the line is going down to the right. And my perpendicular line is going to be positive then. It's going to have a positive slope. And I flip the fraction to 4 over 3. One more like this. And I'll always tell everybody I'm not a genius. I remember these formulas simply because I write them all the time. So if you write them all the time, you will remember them. Label one point x1, y1, the other one x2, y2. So y2 is 15, minus from the formula, y1 is 12. I don't know why I put that in parentheses. It's okay. x2 is 13, minus from the formula, x1 is negative 13. So we get 3 over 26 as our slope. And so that means that our parallel line has a slope of 3 over 26, the exact same thing. And our perpendicular line has a slope that's negative, the opposite sign. And I flip the fraction to 26 over 3. So again, if I were to take these 2 points and draw a line between them, any line with the same slope will be parallel. Any line with this slope, negative 26 over 3, will be perpendicular. It will make right angles. The last way to identify slope, and then of course find the slope of a parallel and perpendicular, would be to identify it from the equation. So here we have slope intercept form, y equals mx plus b, where The slope is the number in front of x. So our slope is 1/3. That means our parallel line has a slope of 1/3. And it means our perpendicular line has a slope of -3/1. Change the sign, flip the fraction. So if I were to write an equation of a line that's parallel to this one, it will have 1/3 x in it. If I were to write a line that's perpendicular to this one, so y equals, it will have -3x in it. And I can just say maybe -3x plus 1. That line is perpendicular to the original because the slope is the opposite sign and the flipped fraction. Slope's the number in front of x, so that -8/3, and so my slope of a parallel line is -8/3. To get my perpendicular line slope, I change the sign to be positive, and then I flip the fraction. So again, if I write the equation of a line, let's say y equals -8/3x plus 2, that line has the same slope as the original, and so that line would be parallel to the original. So if I were to graph those two lines, they would be parallel. They would never, ever, ever intersect. Last one, y equals mx plus b. Whenever there's no number written in front of x, we always assume it is 1, and so my slope is 1, and that means the slope of my parallel line is 1. 1 written as a fraction is just 1/1. So if I need to flip that, I need to change its sign to be negative for my perpendicular, and then I flip 1/1, and I just get 1/1 still, but it's negative this time. So there's some extra examples. Again, if you need help with any of this, make sure you ask for help, and I'll be glad to do that.